Okay, so on page 37 is where we're going to take our notes. We're going to do some examples. And on page 38, we're going to put our notes, although you guys might want to get that into your table of contents first. And we have 2 words worth knowing, so let me go back to that for you. So, first things first, table of contents. We have page 37, 38. Ratios and proportions are what we're going to be talking about. Okay, and then we're going to define both those words. However, I hope they're kind of familiar words to you. A ratio is a comparison of 2 numbers. You can write it one of 2 ways. So you can do this little A and then the colon B, but you say that A to B. Or you can write it as a fraction, A over B. And then proportion is just 2 equivalent ratios. So 2 fractions that are equal to one another. So like A over B equals C over D. Okay. And you can pause it if that's too fast. Alright, so back to the 2 pages we're working on. Like I said, page 37 is where we're going to do some examples. Page 38 is where we're going to put our notes. And our notes look like this. So I'm going to write those out first and then add them in later. So, a ratio. Again, is 2 numbers with the same unit of measure that are divided so that we can fairly compare things. Because if I want to compare 2 numbers, like if I want to compare the length of something to the width of something, if I talk about the length of that thing being in feet and then the width of that thing being in inches, it's kind of hard to tell. I mean, it's not because we're smart and we know what feet and inches are, and we know that feet are bigger than inches, hopefully. But to somebody who may not be as familiar, we want to compare them fairly by getting them down to the same unit of measure. So we're comparing inches to inches, because if they're the same unit of measure, whichever number is larger is whatever length is larger. So that's why we have to have the same unit of measure. So I got 2 examples here, and then we'll do 2 examples or so on our page 38 or 37 as well. So simplify the ratio, 3 feet to 18 inches. Well, the problem here is that we have feet and inches, and they're not the same. So you always have to put your units into the smaller measure. So the smaller measure is inches here. So 18 inches is already good. We just have to change 3 feet. So to change 3 feet to inches, we have to take feet and times it by 12 inches per 1 foot. And you want to make sure that your units cancel out, and so that we are left with inches. So 3 times 12 is 36 inches. The feet divided out because there's a foot on top and a foot on bottom. Okay. And so now that this is in inches, we can fairly compare inches to inches. So 36 inches to 18 inches, and since they're in the same unit of measure, you don't really need that unit, but we should still simplify this ratio, because I think they share 18, like 18 will go into 36 2 times and into itself once. So the ratio is 2 to 1, or 2 over 1, or just 2. And we can use this to set up problems as well. So in the next example, the perimeter of a rectangle is 84 feet. The ratio of the length to the width is 4 to 3. find the length and the width of the rectangle. So if I have a rectangle, with a perimeter of 84, that means I added up all the sides and it equaled 84. We want to talk about the length and the width. So they're comparing the length to the width as a 4:3 ratio, which means that if I call this the length and this the width, along the length there are 4 equal parts. So I could divide this equally into 4 parts, which it doesn't look like it, but it is. And then the width would have 3 equal parts. Because we're comparing them, they have the same units. There are 4 of those units here and 3 of those units here. And since I don't know exactly how big this is, but I know that they're all the same because a ratio is always comparing the same unit of measure, I can say that there are 4 of these unknown values here, so 4x. And then I can say that there are 3 of those unknown values here, so 3x. And again, if I want to do perimeter, I have to add up all the sides. So this length would also be the same, so 4x. And this width would also be the same, so 3x. And so if I wanted to solve for x so that I could find the length and the width, I would add up all of these and set them equal to 84. So 3x plus 3x plus 4x plus 4x. So let's see, 14x. Then divide by 14. And so x is 6. And then once I know x, I can plug it back in so I can find the length and the width. So the length was 4 of those x's, so the length is 24. The width was 3 of those x's, so the width is 18. Okay, now again, proportions are 2 ratios set equal. And there are a couple things that can happen with ratios. So we're going to split this up into like 3 different parts. If I have A over B is equal to B over C, one thing that I can do with proportions and will remain equivalent is I can do cross multiplication. So I can do A times C, bring down my equal sign, and, oop, that's supposed to be a D. B times D. So you can do cross multiplication, and that is equivalent. I can also do reciprocals. So if I have A over B equal to D over C, I can simply flip both and that will still be equal. So you could change this to B over A and C over D, and that's still equal. Another thing that you can do is swap the middle values like that. So if I have A over B equal to D over C, you can swap the middle values, and so you could rewrite this as, and sorry I'm smushing, A over D is equal to B over C, and those things are all equivalent. So you can use any of those things that you want with a proportion, which is kind of nice. Now when you have an equal sign between them though, with a variable on one side, probably your best bet is to cross multiply. That's what we're going to be doing most frequently. So if I multiply across here, I get 30. That's equal to, I have to multiply this whole thing by 3. So that's 3y plus 6. And then I can subtract 6 both sides. So 3y equals 24. Divide 3. And so y is 8. You can do the same thing over here, cross multiply. So if I multiply across here, this whole thing times 7 is going to be 7x plus 14. This whole thing times 5 is going to be 5x minus 15. And so then I'd subtract 5x because it's smaller. And then because my x is going to be left over here, I'd subtract the 14 away. And so we'd have 2x equals negative 29. And then divide by 2. And it's negative and it's not even, but that's okay because we haven't talked about any shapes or anything like that. This is purely like just variables that we're solving for. So it's okay to have negative and it's okay to have fractional. All right, 2 last examples that we'll do on our page 37. So set that aside. So on page 37, I'm going to do a ratio example. And then a proportion. Actually, an extended proportion. Ooh. Okay, so we're going to write the ratio width to length of a rectangle with width 2 foot 1 inch to length 5 feet 3 inches. Okay, so right now these are both in like mixed units of measure. We got feet and inches. So we have to get them all down to 1 unit of measure, the smallest unit of measure in this case, which will be inches. So if I take 2 feet 1 inch, I have to change this 2 feet into inches, and since there are 12 inches in a foot, and I have 2 of them, I would times that by 2. So that'll get me 24 inches so far. But then I have this one other one, so plus 1 more, will give me a total 25 inches. And this is for our width. Okay, for our length, we had 5 feet 3 inches. So I got to change the feet to inches. So since there are 12 inches in a foot and I have 5 of them, we would times by 5. So 60 inches. And then I also have 3 more, so plus 3 would give me 63 inches. And that was for the length. Now again, we are writing the ratio width to length. So we want to do width to length. So 25 over 63 would be the ratio that I write, and I do not think that that simplifies. So that's it. And then an extended proportion is kind of like a proportion, kind of like what we did with the perimeter of the rectangle in that previous example. So if the lengths of sides of a triangle are in an extended ratio of 3 to 4 to 5, and the perimeter is 36, how long is the longest side? Okay, so again, this is talking about perimeter. I'm going to draw a triangle so I can see what the heck is up. So if I have a triangle, if I want to talk about the perimeter again is where I add up all the sides and it's equal to 36. What I know is that the side lengths are in ratio of 3 to 4 to 5, which means that along one side I have 3 equal parts. Along another side I have 4 equal parts. And then along the last side I have 5 of those equal parts. Now I don't know how big each of these equal parts are, but I know that they're all the same because it's a ratio, and so all of my units are the same. But there are 3 of them over here, so 3 unknowns, 3 x's. There are 4 of them over here, so 4 unknowns or 4 x's, and then there are 5 down here, so 5 x's. So really all you're doing is you're throwing an x behind each of those numbers, and then since we're talking about perimeter, we're going to add them all up. So 3x plus 4x plus 5x, and so 36 equals 12x. Divide both sides by 12, and so x is 3. How long is the longest side? Well, out of these, 5x will be the longest because there's 5 of those parts on there. Now that I know that x is 3, that side will be 15 units long. I mean, you could solve the other 2. That would be 12 and that would be 9, but clearly 15 is the longest. All right, that's it for today.